So it is 10 a.m. here in Brussels. Welcome to the KNX application webinar about the topic lighting. Today we're also very happy that this is like the first webinar that we're organizing in cooperation with one of our members. In this case it's EMT Controls, Building Technologies. And I'm very happy that also already more than 50 participants have joined. This webinar is fully booked, so we're expecting a huge crowd for this webinar. Nevertheless, never punish those that are on time, and therefore let's lose no time and get started with this webinar. For your information as well, there will be presenters from 2 companies. That means that we have actually quite a big range of presenters today. My name is Christian. I am basically responsible for organizing this webinar, also with the controlling and everything else which is behind that. But for the topic of lighting, I would rather like to give later the word to our expert. Many of you already know him. He is the one who usually gives the webinars of KNX Association, my colleague Christoph. You will hear him later. Then afterwards it will be also our representatives from EMT Control. So for the webinar's procedure, you might have noticed already that you all have been muted. I think that's just clear because right now we're close to the 60 participants mark, and if everybody would start to talk and we have noise in the background, then we could not really hear what we're saying. Therefore, you're all muted, but that doesn't mean that this webinar is not interactive. You have, like as many of you have already noticed, we have still the chat functionality here in this tool as well. So you can already write down your questions and remark in the chat box, especially if you see that you have or that we have technical problems, so that we can already fix these as well. As said before, we will start first with an introduction of the topic by KNX Association, and then afterwards we will have practical examples followed by the KNX Member EMT Control. I would also like to ask you to keep your questions till the end of the webinar that you have about specific topics, and then after the webinar we will get to each question as time should allow. Great. So that was it from my side and also regarding the procedure, and now I would say let's dive in the actual topic of KNX lighting. For that I'm going to hand over to my colleague Christoph.
So hello and also welcome from me. So as I have been introduced by my colleague Christian, so my name is well known by now. It's also on the slide, by the way, so Christoph indeed. So let's have a look at this topic. So KNX lighting. What I have for you on my agenda for my specific part is listed here. So I will first explain to you how a conventional system, conventional lighting system if you want, or conventional lighting function, how we can convert that into KNX. That will allow me to explain to you the advantages of and the benefits of KNX, and then later on I will talk about, I will have a look at the KNX installation, and I will well, look at it in 2 different ways. So I have 2 views on the same KNX installation, but of course I'll explain you when I get there. Next topic that I will talk about is about objects and group addresses, and then I will talk about the KNX specific lighting functions, so very generic, very general, and that last bullet is actually unfortunately a mistake, so that should not be there. So I will stop right at the KNX lighting functions. So just a general introduction into the functions that we can create, create with KNX technology. And then I probably will have to give the word back to Christian. Okay, we will see what happens when I get there. So first topic. Conventional system, conventional function. So what we see here on the slide is from left to right. So indeed a typical conventional system. So that is a triple switch function. So that means in conventional terms, this is indeed called a triple switch function. What I want to do is to convert it into KNX. So what I will need for that are 3 push buttons and 1 relay actually. And well, let's have a closer look how we do that. So we see here on the bottom, we see here, so if I go back, so this is what we had conventionally, and this is what we have then, so here in the bottom, well, converted to KNX already. So it's a bus cable, all right, to which are different microcontrollers connected, having their own specific role. So what I actually did is I just replaced every conventional switch with a microcontroller. So in case of this, so that is the first thing I will do. So I will do this for S1, S2, S3, but also the electrical consumer. So here clearly a light bulb is also converted, but we see here it's a bit different. So it's a combination of a microcontroller and a relay. Or actually, in summary, every switch that I had in the conventional system is replaced by the combination of a microcontroller and a push button. And the electrical consumer, so again, the light here, is the combination of a microcontroller and a relay. So that is actually how we do this. So I think this is well understood. So therefore, let's have a look at the next slide, because this concept, this constellation has definitely some very important practical advantages. So first of all, the cabling of such system is really easy. Easy means that it saves, one can save a lot of time just because of the cabling, which means that the cabling aspect of such a system is indeed much cheaper in comparison to conventional technology. Such a system is also very flexible. It is really easy to add more sensors, to add more actuators, because what you actually do is you just put them in parallel, so to say. So not only for lighting, of course, this system can be used. You can also add devices that support HVAC functions, blinds, etc. Also important, or not to forget, is that there is here a complete galvanic separation between power, or let's say consumption, and operation. So the power typically here in Europe, 230 volt. Various operation, so in this specific case, so in KNX, that means we are using for that power supply units that of 28 volt. So that's really also safe. So that's for the practical advantages. Then, as such, KNX also means automation, which comes with some extra benefits. So the automation aspects, and especially in the sense of lighting, so what we can offer in KNX is example given. So I have put here a list. This list is even not is far from complete, but these are, let's say, the most important ones, the most well-known ones, the most popular automation aspects that I can come up with. So what are these aspects, these automation aspects? Well, presence simulation. So I don't think I need to explain that. So you indeed simulate presence based on, so that is something that can be easily, let's say, accomplished with KNX technology. Presence detection is also one of the possibilities. We can also include, or includes in the automation of any, let's say, KNX function, and of course specifically also for lighting, the astronomical time, so that we can indeed take into account sunrise, sunset, etc. Daylight availability, alarm conditions, so that could be that triggers come from fire alarm, from HVAC, that have then indeed an influence on lighting. Timers, like typically of course used in staircases etc. Well, the result of all these automation, automation, is that we have a really that we can offer, thanks to this technology, safety. We can offer convenience, but also, not to forget, very important, of course, also energy efficiency. So that's definitely, these are definitely very important benefits. Then, okay, so the next topic is that if we look at the KNX installation, we can indeed distinguish two views. Because if we consider this device here, just this, let's say this rectangle, then actually a KNX installation is a collection of rectangles. So we call that indeed a collection or a network of devices. Each such device has also at least one data point. So a data point could be, well, if I stay on topic, then I could say one data point could be a data point that represents the rocker of a push button. Another data point, again, staying on the within the context, could be a data point that represents the relay of the binary output. And of course, all the other devices also have data points, so that's what we see here. And this is actually the point I want to make. So we can look at it as being a collection of devices having data points. So that means we can look at the devices as such, but we can also just have a look at like this. So just KNX is, well, at runtime, maybe I can put it like that, at runtime KNX is actually this, a connection, a collection of data points. Well, these data points, in the context of KNX, we call those data points actually group objects or just short objects. Then I want to introduce yet a new term, and that is something called group address. So what is a group address? Well, the group address is actually a device independent virtual link between objects. So example given, if I want to connect those data points here, or those objects, so here marked in yellow, if I want to link them, well, then I need to do that by means of a group address. So I call this group address 1. So that is actually an identifier. It's a 16-bit code that I just assign to these objects, and then they are linked together virtually, and as you can see, indeed device independent. I can do this for another collection of objects by means of another group address, so group address 2. So it's just another identifier, it's just another 16-bit code. So we call those codes or those identifiers that group objects together, we call that group addresses. Okay, in order to explain you the next coming topics, I first want to clearly indicate to you what the difference is actually, or how we need to distinguish input objects from output objects. So it is actually very clear. An input object is an object that will get its value from the bus, and an output object is an object that sends its value to the bus. So that means, visually, it means this indeed. So an input object, clearly, we call an object an input object when it gets its value from the bus. When there is an output object, that is an object that will send its value to the bus. So the arrow goes clearly in the other direction. Well, and the typical examples, again, on topic or within the context here. So an input object, so typically, is a relay, because a relay indeed is something that so the status of the relay is indeed something that we will update from the bus. So a relay is therefore seen as is actually considered being an input object. An output object is a push button because whenever the user manipulates the rocker, then indeed the device is supposed to send telegrams to the bus, so to send the updated value of the rocker to the bus. So therefore output object. Okay, so let's have now a closer look, some practical example maybe. So here I see, so what I have put up here is in total 12 devices within, well, a very small KNX installation. And so what we can distinguish are indeed different device types. So I have put them here in summary on the here on the bottom. That is so the abbreviation. So PB, that means that is a push button. SA is a switch actuator. DA is a dimming actuator. BA a blinds actuator, and V is stands for visualization. So that what we have here, so we have 2-fold push button, 3-fold, 1-fold switch actuator, 1-fold dimming actuator, and so on and so on. So you can clearly see what we have in this KNX installation. Now the point I want to make here is that I just want to show you how that there are functions in KNX that just need one group address. So let's make an example. So I've put here and I've put up such a function here. So what we can clearly see here is indeed that I have created a function over that is distributed, so to say, over or where different devices are involved. And also sometimes what we see is, like example given here, that 2 objects of the same device are included, that in some cases even the one and only object of the device is also involved, or where just one object is involved. So you can see there we have a lot of flexibility here with KNX. So in order to well to make my point here, so let's have a look at what's going on. The 2-fold push button here, I see that one of its objects is indeed included in this function. One of the objects of the 3-fold push button as well. The 1-fold switch actuator is also involved. It's only one object and it is involved. 1-fold push button as well. And another switch actuator here is also involved, but only 2 of the 3 objects are involved. The visualization system is also involved, and here we see yet another switch actuator, 3-fold, where only one of the objects is involved. So that's actually the situation, or that is actually the function I have created. Now, in order to have a closer look, let's first get rid of the devices that are not included in the function. So that was the dimming actuator. So it's not in the function. Sorry, that was what? The blinds actuator, not there. Another blinds actuator, a push button that we don't need, and so this is what is remaining. Sorry, also here the blinds, another blinds actuator also we don't need in order to investigate a bit further. So indeed having a closer look means that we in total, what we see in this function here is indeed 3 output objects, 4 input objects, and 1 visualization object. 3 output objects, so indeed the 3 objects from the push buttons, so from the 3 push buttons here, are indeed output objects. They will indeed, these push buttons, they will indeed send telegrams to the bus. So therefore the arrow goes from the device to the bus. For input objects, so what is remaining here is, so I see three switch actuators, but in total indeed 4 objects. So therefore the 4 objects of the switch actuators are input objects, so they get their updates from the bus. So therefore the arrow goes from the bus into the device. And then there is still one object left, that is the visualization object. A visualization object is indeed, how to say, undefined. That means it can work in both directions. You can use it in order just to display information. So as such, it means the visualization object is indeed then input, because it gets its values from the bus. But the visualization object could also be output. You could also send telegrams from that visualization system. And at that moment it is of course an output object. So therefore I called it intentionally the visualization object and not input or output because it's undefined. So okay, that is actually a function that is completely created with one group address. Well, you can already guess what kind of function this is. Well, very simple, of course. This is a switching function. You only need indeed one object, and this object is 1 bit. It's either on or off. So that is quite clear, I guess. And okay, so let's have a look at another situation then. That is where a complete function actually needs 3 group addresses. So let's have a look at the same installation, but we shall create now a different function. So I need one group address, yellow, in order to link the yellow objects here, or the objects colored in yellow, and another group address, so green, so this will link the objects now colored in green. So now colored in green, and another group address, blue, that also links here, as we can see, also 2 objects together. So let's get rid of of the devices that are not included or not involved. So the 3-fold push button, the 1-fold switching actuator, another switching actuator, blinds actuator, and also blinds actuator. So this is what is left. And so what we can see here now, if we look a bit closer, is that this 2-fold push button, that 2 objects are involved. The 1-fold push button, also 2 objects. Here I have a 3-fold push button. There's only 1 object involved, and it's only yellow. We don't see green here. And then there is the dimming actuator, where all 3 group addresses are involved. Visualization system, only 2, only yellow and blue. So we can see here that also, yeah, the other dimming actuator, sorry, I should have removed it first, is also not included. So that is the function that we have created. So what actually is going on here? First of all, I can tell you that yellow is actually the group address that we will need in order to switch the lamp. The lamp, which is obviously connected to the dimming actuator, and we need yellow in order to switch it. So the switch is represented in the push button here, in this push button, and in this push button, and of course also on the dimming actuator. And that indeed will, so if telegrams would come from the push buttons, it would indeed have an influence on the dimming actuator. What we also see is that the switching data point is also included in the visualization system, so we will also be aware of the status of the lamp in the visualization system. Is it switched on or is it switched off? Another group address that we need is for relative dimming. This is 4-bit information. So we see that green is used in the 2-fold push button here, also in the 1-fold push button, but not in the 3-fold push button. And this is perfectly okay. This is a situation that we can create, because maybe the customer indeed wanted this push button only to use for switching on-off. He didn't want to use it for the relative dimming. That could be a requirement. Yes, why not? And of course, the relative dimming is also represented, of course, on the dimming actuator itself. Otherwise, it would, of course, not work. And then there is blue. What is that? Well, that is the value. That is the 8-bit encoding. Also, that is an 8-bit encoding. What is that actually? Well, that is to know the percentage actually to which the lamp is dimmed. Is it dimmed to 50%, to 60%, or whatever? And that is the information that we indeed need on the visualization system, or that could be useful for a visualization system as well. The visualization system could also, by the way, use the yellow also to switch the lamp from there, or even to directly indicate in one go what kind of percentage that I want to have for the lamp to where it shall be dimmed. So just in one go, in one command from the visualization system. So that could also be a possibility that KNX can offer here in this case. The visualization system could, by the way, be also an app on a smartphone, just to explain you the use case. So anyway, looking at the function or as summary, I can say that indeed this function here is so a dimmable lamp obviously exists here out of 5 1-bit objects, so 5 times yellow, indeed 1, 2, 3, 4, and 5. 3 times 4-bit objects, 1, 2, and 3, and 2 times 8-bit objects, so 2 times blue. And that is also, well, this is actually a situation where we need 3 group addresses in order to have a complete function, so obviously for dimming here. And then as the last part, I just want to give you in summary the general overview of some lighting functions, and then I will give the word back to Christian, who probably will then give the word back to EMT Controls. But okay, first I will end with my part, of course. So switching, so we have seen indeed what we need there is indeed just one group address, so minimal, that's the minimal requirement. So just one group address for on-off, okay, clear. So divided over a push button and a switching actuator. For dimming, we only need, well, minimal 2, so that is also divided over a push button and a dimming actuator, of course. So 1 for switching and 1 group address for a relative dimming. You might wonder, okay, where is blue now, or where is the 8-bit code? Well, strictly, I mean, strict sense or principally, you don't need it in order for dimming, because the relative dimming is enough for dimming, right? So therefore I limit it to 2 group addresses here. Then another application is where we include visualization. We also have seen that in the example before, so let's just go quickly over this again. So one group address divided over a push button, the dimming actuator, and the visualization system for switching. Relative dimming divided over the push button and the dimming actuator. And then, so as we have seen indeed already before, the value percentage 8-bit code for divided over the dimming actuator and the visualization system. And then this is my last slide this is the last slide of my part. Movement detection is also another possibility. So let's have a closer look there. What we need is a group address divided over a two-fold push button example given, a dimming actuator, and yet another device. It's called a movement detector for switching. So that means that indeed the movement detector is also possible. So the movement detector is also included in the switching group address because indeed it should also be able to switch on the lamp based on detected movement. So that is why we also have to include this in the same group address. And then there is the group address too for the relative dimming, so divided over the push button and the dimming actuator. And then there is yet another link, but this time not between the dimming actuator and another device, but it's between the same push button and the movement detector. And now you probably might wonder, why do we need this? Well, this is for blocking the detection. So what this actually means is that, of course, we could find ourselves in a situation where we don't want the movement detector to influence the lamp, to switch on the lamp. So therefore, we need indeed something that blocks the detection, and therefore we need this third group address. So again, divided over the push button and the movement detector. So okay, that was all I had to say, all I wanted to share with you. So I now give back the word to my colleague Christian. Thank you for your attention. Sorry.
So, thank you very much, Christoph. That was, I think, very interesting for us to know, like, how it works as part of the theory with KNX. But now we actually come to our highlight, our little premiere. After we've learned how it works in theory, we will now have a look at practical examples. For that, I'm very happy to have our first exclusive presenter here, EMT Controls, which will present basically how they put this kind of knowledge, which was just delivered by Christoph, into practice. For that, I'm going to give the word to Mr. Cem Vardar, who will then later keep on presenting his solutions that he has like exclusively available. Also, he is supported by his colleague Dimitri, who also has now been unmuted. Now I give the control to Cem. And now I would say, Cem, the floor is all yours.
Hello. I hope you hear me now.
Yes, we do hear you.
It's okay, great. And can I have the controls of the presentation as well?
You have them.
Which I do not see, unfortunately. Christian, I'm afraid I don't have the controls of the presentation.
Yes, you do. You're changing the presentation right now.
Ah, I'm changing. Okay, yes. That's me changing. Good. Can we go back then in 2 times?
Yes.
Yeah, thank you very much. So, hello, my name is Cem Vardar. I'm the founder and CEO of EMT Controls company. As you might be familiar, KNX is the umbrella organization putting together vendors and system integrator partners and put all effort to guarantee interoperability. To control the overall experience, integration of multiple parts is essential. Thus, we follow the KNX way. Thanks to Christoph for talking on the theory, thanks to Christoph on talking theory, today EMT team will be talking about real-life examples of lighting automation. Before that, I would like to take the opportunity to tell a bit about EMT Controls and why we do what we do. EMT stands for Experience Management Technologies. In the human-centric society of 21st century, fundamental part of perceptual experience is the lighting. Because traditional living environments are not optimized, traditional electric systems put too much responsibility on us, the human, to keep them efficient and secure, we thought a lot and put our energy in designing tomorrow's living environments. We manufacture hardware and software that is used to manage the experience. Lighting influences sensations of people. So today we picked lighting automation as the first topic of KNX webinars. Now my colleague Dimitri will be guiding you through the ideas and technologies for lighting automation using the KNX technologies.
Thank you, Cem, and hello everyone. My name is Dmitry Naumov and I'm leading integration engineer at EMT Controls. Today I will be your guide in the world of the lighting automation technologies through the EMT Controls experience. First of all, I want to pay attention to the navigation panel with the points which will be highlighted in this webinar. Sorry. Christopher, I'm sorry, do I have control? Yes, seems yes. So, data, introduction. This block includes general information about lighting automation technologies and goals. The KNX system capabilities. This big point of the presentation is dedicated to the KNX-based lighting automation systems, functions, and abilities. For easy material understanding, we divided lighting automation into 3 levels of complexity. Next one will be 3 myths about the KNX. We gathered the main pains of the KNX system users to dispel them with our technologies. Examples. The chapter where we will get a real-life experience of the system architecture to use them in your installation. System integration workflow. We decided to share our internal methods of how to build the system architecture easily and make it commissioning. Conclusion. We will sum up the results of researched information and will answer on your questions. So please make notes during the webinar and we will try to answer for them all. Okay, let's start our journey. Lighting is one of the most aesthetic and beautiful things in the building automation. It is an effective tool that can highlight special elements of interior and exterior design, create a unique atmosphere in the room, influence the guest's moods, or even warn about the danger. Lighting is used in all areas of human living and activities, so lighting automation system can be useful for all spheres of the human life. There are many ways to manage lighting in your system. From one hand, simple user interface, comfortable for the end user, and presented by a simple touch panel or smartphone application. On the other hand, it can be centralized control from the server software and scenarios based on the lighting control. Anyway, basic actions for the light functions is tuning on or off, dimming the light brightness and usage of pre-designed lighting scenarios, or interact with the user, detect his movements, gestures, and so on. For this purpose, a wide spectrum of KNX devices are used. Wall panels, switches, sensors as elements for user interface for the system. Dimmers and actuators as elements of electrical control of the light itself. Gateways, interfaces, converters, repeaters, couplers, power suppliers for the service purposes, and the controllers, smart devices that can perform control of the system in the higher level. Artificial lighting is one of the basic applications of technology in everyday life. Built-in automation systems can be presented in any living environment. We want to take away the tasks that the system can do by itself from the person, or provide with the quick and intuitive user interface for lighting control. It is Turing KNX communication protocol provides an ability to create reliable and functional lighting automation systems. Next slide will show how to do it in the default as much as possible in the half-an-hour webinar. Here is the second chapter, KNX system capabilities. Based on the KNX bus system, we can be in a few levels of complexity that depends on the building area, type, and its predestination. Let's start from the simple KNX-based architecture. As you can see on the scheme, it includes the built-in user interface represented by the touch panels and light sources. Touch panel performs simple on-off switching, dimmable light control, or control of individual lights or a group of the light sources. The connection between touch panels and lighting is performed through the KNX line. Devices are connected with each other by the same line. In our case, it's twisted pair wire, and they are powered from this line too. The connection is provided from each touch panel button directly to a particular light source or the group of them. Two lamps are driven by a KNX actuator that can make them on or off. Now this actuator is getting command straightly from the touch panels. Actuator regulates giving the power from mains to the lamps. However, digital part of the actuator is commonly powered from the KNX bus. Our third lamp will be driven by the dimmer. So now we can control the brightness of the light from the touch panel, since it's already a standalone solution. It is a sufficient solution for the small home, one room, or a small office. Mobile application user interface, remote and centralized control are not supported by such solution, and with this level of complexity. Let's take a look on the level 2 of lighting automation system complexity, which includes the smart controller. It is the main device which provides more flexible system logic and more connectivity. Smart controller, which we call RCM series, is the brain for the automation system. It receives requests from the user interfaces and gives commands to them as messages. Our controller supports Wi-Fi, so a user will be able to control the lights from a mobile application. It is enough to connect the same local network with your mobile device. This solution is suitable for villas, commercial areas, or shops, or offices of middle complexity. RCM controllers, in combination with motion or real presence sensors, can run lighting scenarios depending on the contents of the sensor records. For the system activates a specific scenario when the guest is coming, moving, or even when he is asleep by the unique real presence motion technology. Also, scenarios can be based on other events and actions, such as very abstract cases in a hotel room with RFID card access integration based on RFID card type, having different light for the housekeeping or staff or the guest. You are able to configure lighting sense and tune and fine for your interior. Also built-in real-time clock, allow time-based scenarios as well. By adding to the system architecture the software for centralized control, we are getting a highly integrated automation topology. It can be implemented for big complex buildings such as hotels, hospital, cruises, airports, even for the controllable street lighting. Software management system is a tool for full control of the complex automation. It is the top of the system. Such software is running on a server PC and has access to all main controllers that connected as a common local network. The software interface allows the user full access to setting, editing, controlling, monitoring, analyzing all parameters of the automation system. But what about flexibility of such solution? Let's assume that this lighting automation topology, most complex one, is a just single block for the huge infrastructure. So each controller becomes a core for the small universe of devices, of lighting, of everything, where multiple universes can be connected and centralized visualization and control software through IP connection. The group of such blocks create the automation of entire building and gives the ability to manage it centrally, control each floor, room, and area separately. In such case, centralized controls can run on TCP/IP network, and the room or floor level integration is fully KNX based. Also, there is no tangible restrictions on the number of devices controlled by the network. Each KNX network provides the ability to gather more than 65,000 of points at the same time. As we know, only electrical limitations of the bus may play a role in this maximum quantity of the devices and subsystem. Including multiple buildings, the entire management software provides control for all of them centrally. It is also allow you to gather the energy from the consumption statistic from all buildings and provides you with the ability to use the predictive energy saving technologies, for example, based on the artificial intelligence. The software may initiate an automation system and all electrical loads to work more economically by proper lighting usage based on the experience in the past, or turning on special energy saving scenarios for this. So next, our part will be dispelling 3 most common myths about KNX. We know lighting designer well, so we are aware of what they are afraid when choosing the protocol for lighting automation. Now let's take a look at the 3 most common myths about KNX and how we are solving them. Number 1. People think that it's hard to control different lighting technologies through the KNX. This problem is the most common among system integrators that fall into the project when it's already started. When the automation system logic has already been designed prior to them and there are other communication protocols, but their demands is to create automation of the lighting based on the KNX, it is necessary to have the ability to unite all devices that you have in the project into one single system. KNX manufacturers has all sorts of the lighting, driving and gateways products that supports all protocols and technologies. Gateways allow to make a connection to devices such as dimmers or ballasts on a different common protocols in the IoT market. RCM series controllers and other EMT gateways provide various integrations that you can see more at our website at emtcontrols.com. The second myth is about a problem of selection of beautiful design for the touch panels, switches and buttons for providing an aesthetic and user interface for the visitors. The power limitation on the KNX bus has made it impossible to create touch panels with the illuminated icons and the fine manual controls. Manufacturers of the switches were constrained within standard power limits, and their products were not pleasuring the aesthetically and as primitive as possible. Making a good illumination requires a high-tended current consumption, which is hardly achievable by the taking power for device from the KNX bus. As we know, normally KNX devices are taking the power from the KNX bus. That's why the goal of the manufacturers of the KNX products is to make devices to consume minimal power. KNX power supplies are limited in their possibilities, and KNX models inside of the device can't provide a big current, so bus is not capable to drive a big loads or a big amount of devices without special hardware elements. However, the good illuminated devices will consume much more current for their operations, and the KNX bus will be unable to power them all. Hopefully those days have been past. KNX remains a low power and energy efficient system, and it delivers intuitive user interface still. Modern KNX-based built-in touch panel series provides innovative user interfaces for simple and intuitive lighting control. These days, users are able to choose from a variety of devices and variety of capabilities inside the device. For example, dim the light brightness with the touch panel with radial slider. Brightness adjustment at the touch panel with the linear slider also is available. Choose the basic touch panel for the haptic control of a few different light sources or the group of the lights simultaneously. Or apply innovative voice user interface by touch panel with integrated Amazon Echo Dot. Just ask the device to change the lighting on your demands and it will do it for you. Choose modern innovative technologies for built-in touch panels and use them for the lighting automation on the KNX bus. Modern touch panels become elements of our devices with a beautiful glass surface and intuitive design icons. They are fully customizable in all ways of them. For example, you can choose on your choice the glass color, icons layout, backlight of icons from the RGB touch panels, backlight brightness in different modes and color feedbacks, or adjust the sensitivity of each button. It's all in your choice. The third myth is about difficulties of the lighting automation. Configuration is hard or limited. Lighting designers might be demanding. We want you to be sure that now these are ways to tune the entire system without any special education for it. We have been working for years with lots of system integrators from many companies and countries around the world. And we have developed the intuitively understandable user interface of parameterization library to facilitate the configuration process. ETS library contains all settings and easy-to-use view to provide a user with simple system integration possibilities. Thankfully for the huge KNX partners community, today ETS libraries cover almost all real-life usage scenarios, and you could easily tune it to match your interior. ETS library provides the full access to all parameters and objects of the system to program the necessary behavior of it. For example, you are able to choose from different modes, delays, level of brightness, actions, sequences, rules, binding, links. Anything is available for modification and tuning. Right now, I would like to present you 3 projects of EMT Controls to consider by examples real KNX-based solutions for the lighting automation of the buildings or many of them. We will have a short look on the rooms in the Hilton hotels, residence the address in the 5 mega towers, and a short look for the 370,000 square meters giant hospital complex in Mersin. Hilton is one of the most famous and represented hotel networks in the world. From the early development of the new hotel complex, it was decided to create a fully KNX-based topology. In one of the projects, we had 5 buildings connected by KNX AP backbone. Each of them has 5 floors in each building and 250 rooms in total. In every room, automation is based on the room controller that serves as a direct processing of the lighting and manages the light sense, informing the centralizing system about sensor state. So even at absence of the backbone, a room is independently operable. EMT automation software is using KNX API Gateway that provides ability to manage KNX devices in all areas from one user interface. You can control not only the state of the lights in the system, but also to create the sense for them and to monitor power consumption of single light room or whole 5 buildings, all through the KNX network. Also, you can do actions based on the guest check-in and check-out. For example, you can adjust different temperatures for arrival, you can adjust different scenarios for the check-ins. All is fully available from centralized user interface. Next example is the address residential. In this project, KNX is used at every apartment, but unlike other systems, it has much deeper integration with the user. For instance, the room controller supports several users for one apartment, while each user could have their own lighting experience of control due to individual scenarios. Along with the sensors, there represent about 25 KNX touch panels for each apartment type, which allow individual or according to the scenario's light control. All telegrams are stored in the controller's memory, and when required, light condition is restored to the previous state when exact user was in the room previous time and returns to it. The system also contains devices with the third-party protocols, and we used our KNX Daily gateways to control lights through the KNX. City Hospital in the Mersin, it's a huge complex of 4 giant buildings where each single light is controlled by KNX. All lighting system is connected to motion and ambient light sensors, which are located at KNX bus, and they are defining the system behavior. From our side, we are forwarding the control commands to the target light sources via our KNX gateway, thereby providing the ability of the group or individual lighting control. Server software, in this case, communicates to the system via local network, thus forming the KNX API backbone. A very interesting implementation is calculating LED efficiency over time. Ambient light sensors and dimming percentage allow our server to calculate LED brightness decay over the time. So after a couple of months, one can see the LED performance if it can be generate same amount of the lights as at given settings. We believe this is a very special implementation for the KNX-based lighting automation, especially for performance based on the LED lighting contracts. Half of the correct project realization is the detailed information about system automation system logic. We know how the quality of lighting automation work affects satisfaction of the visitors of your building, and the depth of the company is which is providing the automation services is to ensure that correct operations and reliability of the system. To be able to guarantee a clear setup and settings, which is important, it is important to know all project details from the beginning of cooperation with the customer. So we are trying to help our partners with project planning and management. For smoother deployment, and improved end experience of end user. To cope with this task, we have created a system for deep immersion into a big project. At the start of each project, together with customers' representatives, we fill out a special documents, the project description file, in the course of which we are finding out all the subtleties, connection diagrams, and desired scenarios. On this basis, we do the project planning and provide you with all necessary materials. So, what do we get as a result? At the first, we found... Hello? Is someone joined us?
We hear you very nice, Dima. Continue.
Thank you. Okay. At first, we find out that KNX-based learning automation is suitable for the solutions of any complexity, regardless of building size. The good point that EMT Controls is providing the wide range of KNX-based products, and they are covering the entire spectrum of lighting automation projects. We are here to provide you our experience and technologies in building automation and create the best projects, improving the quality of the human living environment with the care of their comfort and satisfaction. Please visit our website to get more information about technologies and products for building automation and the lighting. Our contact is directly to get a free consultation from the automation experts by mail. Thank you very much for your attention. We hope this information was really useful for you. It was an honor to us to address you in this framework of the KNX webinar. Thanks to organizers for this opportunity.